Hello everyone, welcome to Etteplan's webinar about embedded security. Today the topic is the era of non-secure embedded devices over. Welcome IEC 62443 standards. Today we will have an interesting webinar with three different parts. We will start by an introduction of the speakers today. Let's please start with Jussi, who's our guest speaker.
Hello, Jussi Valkiainen. I'm Head of Product and Application Security at KONE.
Hi, I'm Jarmo Lahteranta. I'm working as a cybersecurity specialist at Etteplan.
Hello everyone, my name is Antti Tolvanen. I work in sales at Etteplan Software and Embedded Solutions, and I will also be facilitating this event today. Our agenda today is the following. I will start by presenting some of the regulatory changes that are being prepared in EU. I will also touch a bit on US and then also show why it's a good idea to base embedded development on the IEC 62443 standards. Then Jarmo will proceed in discussing about next steps for practical approach to applying 62443 in embedded development, and then Jussi will wrap up by telling how KONE handles security in product development and especially related to the DX lifts. Okay. A quick introduction to Etteplan and why we're talking about security. So we're an engineering services company, mid-sized, publicly listed with a good global coverage. Our main service areas include engineering solutions, where we make devices, products, manufacturing lines, complete factories, where we use mainly commercial PLC technologies as the control systems. Me and Jarmo were representing the software and embedded solutions, where we make customized control systems for our customers' devices related to IoT and also power electronics, and we also develop and maintain business critical software solutions for our customers. And then our third business unit is technical documentation, where we make installation, use and maintenance instructions into publication formats that support cost-effective publication in many different channels. So security is relevant for all of Etteplan's business, and especially looking at our customer segments that we're working with. Many of the customers that we are serving operators of essential services or critical infrastructure operators. And thus, developing secure product is very important for us. I will then start explaining a little bit what's happening on the regulatory front. One important directive for everybody that is working on device development is to know the NIST directive from 2016. This was a directive in EU where it was made mandatory for the EU countries to have national cybersecurity capabilities, basically computer security incident response teams to conduct cybersecurity exercises and such. There was also founded the EU CSA network, and this directive also stated that this kind of critical market operators should be supervised on national level. On national level, these operators are also selected, and also different kind of security process requirements for these critical infrastructure operators are defined on a national level. So critical infrastructure is in the NIST directive split into two parts. There's the operators of essential services that include digital infrastructure, energy distribution, healthcare, hospitals and private clinics, drinking water supply and distribution, transport covering road, cars, trains, ports, airports, then the financial sector, and there's then also parts of the NIST directive is affecting also digital service providers, basically online marketplaces, search engines, and cloud computing service providers. what you should here know, I'm going to present kind of the next page why this list is important to understand, and also you should keep in mind that the list, this NIST directive is currently being reviewed, and looking at the feedback from many European trade organizations, there's lots of discussions with the list of operators of essential services and digital service providers be expanded. So this is something to keep in mind, is that there's this list of operators of essential services, and it's good to take a look at that. So this happened in 2016, and after that in EU started the preparation of the EU Cybersecurity Act, and this is kind of the main beef that I will be talking about today. So EU Cybersecurity Act has two main parts. The more important part for equipment manufacturers or designers is this upcoming EU framework for cybersecurity certification of ICT products, services and processes. So covering both products and systems and software. And the objective was having this kind of cybersecurity certification schemes is to develop a single market for IoT devices in EU. Today it's like that. The regulations are on national levels, and they could be, for example, for electricity meters, national level approval. So one of the objectives is to promote the internal market and competitiveness development of European companies. The objective with cybersecurity certification is that certification will be voluntary unless made explicitly mandatory by EU or member state law. The second big thing in this EU Cybersecurity Act is that it mandated the EU Agency for Network and Information and Security. And NIST is working on preparing now for the Commission these cybersecurity certification schemes that are specific for different products, services, and processes. Or that was the thinking back in 2019. Let's on the following pages then look at what has come out. In the EU Cybersecurity Act, they had already listed security objectives that can be seen as process and design requirements that should be included in the certification schemes. So that's kind of one task of NIST. The second one is to defend EU against cyber attacks with focus on the operators of essential services and digital service providers. And if you represent a company that develops devices for the critical infrastructure, it's very important to understand that NIST is providing these operators of essential infrastructure, let's say electricity companies and hospitals, private clinics, with advice and guidelines related to purchasing of secure equipment, devices and systems. So NIST is actively both developing the certification schemes and developing purchasing requirements related to systems. So that is it's important to follow up what NIST is doing. And here you can also hear that the market is expected to develop the market is expected to change by first the operators of essential services tightening their purchasing practices related to cybersecurity of devices and software and services, and then later on there will be cybersecurity certification schemes, either voluntary and mandatory. Okay, then in looking at the EU Cybersecurity Act, there will be a transition from mandatory certifications to voluntary. The first mandatory certifications could be expected sometime between 2023 to 2025. And EU shall assess the first published or voluntary certification scheme latest by 2023. Well, the recommendations have been published already this and last year. We will look at which those certification schemes are. And then assessment of all the remaining certification schemes that have been published should be done at latest 2 years after the publication of the first one. So none have been published officially. The recommendations are public. And then after the assessment of these certification schemes, EU they will decide shall this be harmonized as standards that should be used either on EU level or not. So basically the first one could be expected in 2023 and latest in 2025. And these are important years to understand why you're planning the roadmaps for developing your product portfolios and their security capabilities. what these certification schemes are about. It's good to understand that there are certain process requirements and there are certain design requirements for the devices, and the certification schemes objectives are to basically do quality assurance that requirements are met. In the EU Cybersecurity Act, there are 3 assurance levels. It's the basic level. So at the basic level of the device, of security, the device should, during device development, the known basic risks of incidents and cyber attacks should have been minimized. And then technical documentation of the product development should be evaluated, both related to the development process and the device itself, that it contains the security functionalities. And on this basic level, the manufacturer can, it's planned that manufacturer can themselves do the self-assessment while doing the CE marking or use an accredited conformity assessment body. Then on the substantial level, here the objective is to minimize known cybersecurity risks and have some resistance to cyber attacks that are carried out by actors that have limited skills and resources. Basically, it's the scope of activities that as on basic level, but then the assessment team that does this assurance should do verification of the security functionalities of the device, and then also test that there are no known vulnerabilities in the device. So basically, on a substantial level, there's a third-party review of the design documentation, and also basically design documentation related to the design process and the device requirements and verification itself. And this shall be done by an accredited conformity assessment body. And then on high level, the objective is to minimize the risk of state-of-the-art cyber attacks carried out by skilled attackers. And on this level, the security functionalities should be implemented and verify that they're implemented at the state-of-the-art of technology, and then the device should and the systems should have a resistance to penetration testing by skilled attackers. The certificates will be given out by national cybersecurity certification authorities, country level, or then accredited conformity assessment body to whom these national authorities have delegated this responsibility. So this is how the certification scheme assurance levels look like. Okay, this information was pretty much known already in 2018, and then concurrently while the Cybersecurity Act was processed in EU, different industry organizations started to investigate how to, on practical level, implement this. One very interesting document or piece of work that has been done is the EU Smart Grid Task Force that investigated how to what kind of certification scheme would be suitable for electricity sector. And they concluded that the EU Cybersecurity Act assurance levels are well in line with IEC 62443 standard security levels. That was a very interesting finding. Jarmo will later on go into detail about the security levels. And then they also noticed that related to certification schemes, they proposed that for the electricity network operators, their certification scheme would be based on IEC 27001, 2 and 19. And then for product device suppliers and system integrators, the certification schemes would be based on 62443. So these were their recommendations about 1 year ago. Then when going forward to looking at what kind of cybersecurity certification schemes are going on, and also all other regulation in EU. So this is kind of what can be found. So I've found on the internet 3 different certification schemes. There's one for so-called operational technology. It's focused in on industrial control system components. There's several different standards that are applicable, including 62443. I will discuss this in more detail. Then perhaps the first one that will become effective is the EU Common Criteria Certification Scheme that's based on the IEC 15408 standard for IT equipment like firewalls and smart cards. The third one that I have found is cloud service provider cybersecurity certification scheme. So looking at this, it looks like there will be a certification scheme coming for cloud service providers, software as a service providers, and basic cloud applications. And it looks like the applicable standard was 27001, or basically then depending on what industry you're operating is the 27000 series. Meanwhile, in EU, there has also been for the 2 years ongoing the project for regulating 5G technologies. This has been lots in the news, and an EU toolbox for risk mitigation, cybersecurity risk mitigation has been published. Then also there's been lots going on related to consumer IoT devices. There's a new ETSI standard, a new version came out, and some in Finland, the Tietoturvamerkki has been implemented as a voluntary standard, and in the UK they've been working on also implementing some of the main design requirements. In addition to these certification programs, there's also sector-specific standards and regulations that are being developed for automotive and medical. And currently it looks like it could perhaps be possible that in these areas where there's strong sector-specific regulation, perhaps there would not be a separate kind of certification scheme. But I'm not certain about that yet. It's good to notice that maybe these ICS components could be valid for non-medical equipment that is, for example, going to hospitals or to healthcare sector. And in order not to make this too simple, there's also ongoing work for making a delegated act into radio equipment directive in order to regulate via RED all IoT devices, all devices that have radios. And there's currently industry organization feedback for this update of RED going in. Probably this will at least affect consumer devices, but it could very well end up that RED directive will include requirements that form the baseline of cybersecurity of connected devices in Europe, of the devices that have radios. But this is also very much in development, and there's not that much public information, but the notified bodies are well involved, and they believe that this is one of the ways how devices will be regulated. So consumer IoT might be kind of, RED directive might define that, for example, for consumer IoT, the ETSI standard will be an applicable harmonized standard, and it could potentially also be, I'm not certain about that it could work in the similar way with connected devices in operational and information technology. Let's see how this RED update goes. In case you want to know more about the cybersecurity certification schemes, I would propose that you listen to the ENISA Cybersecurity Certification Conference on December 18th, where they will tell about what certification scheme they are working on and what are the next steps. Okay. What you should know about the industrial control system components certification scheme. So this is a recommendation. It was published in September 2020, and in the introduction, they concluded that security starts from kind of the hardware level or the component level. So this is why for operational technology, the cybersecurity certification scheme is focusing on the component level, the embedded device of the control systems of the software, and then kind of that's how they will be regulated. And in this certification scheme, they have also described what kind of evaluation activities are needed for the different assurance levels, and very nicely listed also the applicable standards. So it's good to know that this recommendation is the 62443 is well represented here, and it's also possible to utilize the 27000 for the design lifecycle pros, and then also the IT systems or the consumer IoT standards for the design requirements themselves. Then if your market is in US, you should very much be aware that the US Senate and Congress have now passed the IoT Cybersecurity Improvement Act of 2020. It's next going to the president. So basically, the National Institute for Standards and Technology Series 8259 series is likely to become mandatory if you want to sell IoT devices to US federal government or to entities controlled by US federal government. And basically, this is very close to being a definite fact. So early 23, the US federal government should apply these standards in purchasing of devices. Related to USA, and if you represent medical technology, we've been waiting for the FDA guidance on pre-market cybersecurity for quite a while, and I'm myself wondering that have we been waiting for this baseline to prepare. I've seen in earlier communication some kind of thinking that there's a baseline for everything in the federal government, and then there might be some kind of a medical device sector baselines that have additional design requirements. But it remains to see how the FDA will in the end up regulating cybersecurity. Now there's only the draft guidance. Okay, then Etteplan. We have seen that the 62443 series is a good basis for secure embedded development, and there's many different reasons. So there's a high probability when we follow the standards that were in line with EU Cybersecurity Act and upcoming IACS component certification scheme standard. We probably all the different standards have a pretty good overlap related to requirements, so we will probably be well in line with the Radio Device Delegated Act, also with the US IoT Cybersecurity Improvement Act, and then also with the different operational technology related security standards and regulations. It's for example in medical and in automotive. Both medical and automotive are building sector specific security standards based on 62443. And then also by bringing in personal data related security standards or privacy standards, these can be brought into the project if they're needed from the consumer ETSI standards or from the upcoming medical device standards for security in case additional requirements are needed, or then to utilize for these requirements some additional standards. So our design teams have concluded that the 62443 provides clear requirements for both the process and device in secure embedded development, and there's also available accredited testing and certification service providers in case our customers see that having certified security certified devices to the market is good for the competitiveness, and we also see that it's quite likely that the market demand for secure embedded development will grow rapidly due to EU and US regulatory requirements coming into full effect over the next 5 or 6 years. So this was my part. I will also show you here the sources that I have used for my presentation, and I would like to bring up one very interesting party to follow in case you want to see. So it's a Certex. There's a handful of accredited certification bodies for 62443, and Certex is a Swiss accredited body that's specialized in safety and security of operational technology and especially embedded. So they're working in industrial, medical, and automotive, and they're also part of the ARM ecosystem for security certifications, and they are accredited in 62443. So that's a very good company to follow and cooperate with. Good, that's for my part. I would now like to give the word over to Jarmo.
All right, let's continue.
Oh, by the way, in case you have any questions, there's the questions and answers functionalities here. So please write your questions and we will go through them in the end of the presentations.
Yeah, so now let's talk about this IEC 62443 standard. Now, this is a pretty big standard. It's divided into 4 main parts. So the parts 1 and 2 actually apply only to the companies which are running the automation and control systems. The part 3 is for the companies which are building these systems, and the part 4 is for the companies which are building the components for these systems. So we'll be only looking at this part 4, and here's a typical IoT network. And in this network, the components would be the IoT node / embedded device and the gateway device. And my point of view in this presentation will be about creating this trustworthy and secure hardware platform. And Jussi will have a bit wider view of these things. So let's look at these embedded devices. So actually, what is an embedded device? Well, it's smart anything. So smart computer, smartphone, smart microwave oven, smart electricity meter. It's anything that's doing computing but is not a computer. So they might be very low powered, they might run on battery for many years, or they might be high powered systems running an embedded Linux operating system. And the heart of the system is the MCU or the SoC, which comes from microcontroller unit or system on chip. And that's the thing that does all the processing basically. They might also have some memory, some display, buttons, LEDs, or whatever you need for your product. And finally, they have some both internal and external communication buses. So the unique problem with embedded device security is that you can assume that the attackers have physical access to the device. Now, all of these devices are built in layers, and vulnerabilities on the lower layer can actually break security on the higher layer. So on the bottom, there's the hardware, then you have some sort of operating system running on top of that, and finally, you have the application on top. Now, let's say that our application has a database which has some secrets, and because they are secrets, they are encrypted. But the application also needs to have access to the database and those secrets, so the application has the decryption key. Now, if the attacker has access on the operating system level, they can just get the same key that the application is using, and they can get access to those secrets. Likewise, if the operating system is really well hardened, but the attacker can maybe read or even modify the flash contents on the hardware, the flash memory of the device, then they can just remove all your protections that you have placed in the operating system level, or even just again read the keys and data directly from the memory. So how do we create these secure devices? Well, this is a pretty simplified outline, but we need to start from the hardware. We need to have hardware which has enough secure enough components. So features like immutable root of trust, memory protections, different isolation levels. But just having secure components won't do you any good if you're not using them properly. So we also need to figure out how to combine these features to create this secure system. So basically, we think about what are the assets we want to protect? What are the threats we are faced with? And then we combine this, and we can get set the security requirements to mitigate those threats. In the next step, we dive deeper. We think about what it takes in practice to implement these requirements. And yeah, like I said, this is a pretty simple outline, but it just shows the big picture. So now we're actually building the device. Now we need to avoid creating vulnerabilities. We need to make sure that we are hitting those requirements. We're writing high quality code, and so on. Now, while we're developing this device, it's in a really open state, so you can basically do whatever you want with it. But in the next step, now that the device is finished, we need to put it in a secure state so that all the debugging interfaces are disabled, and it also gets its unique identity and encryption keys and that sort of stuff. So basically, at this phase, it needs to be ready to face the cruel world and all the attackers who will attack it. And finally, we have the maintenance phase. So our device might have a lifespan of maybe 10 or 20 years. So we need to be able to supply security updates throughout this whole life cycle of the device. Now, you can see that all these features actually rely on the work done on the previous stages. So if you don't have secure hardware components, then you can't really do that much on the design phase. And likewise, if you haven't done your secure design and architecture, and you're just in the implementation phase, then you're just wondering about, well, should we add some security, and what's the context for all these features that we are doing? So it really required in all of these different stages. And if we flip this on its side and look at it in a chronological order, it fits there pretty nicely. So the hardware components are selected in the requirement stage, and it goes on from there. But yeah, I guess we were here to talk about the standard, and here it is. So the -4 part of the standard is actually divided in two. So there's the -4-1, which is about the secure product development lifecycle, which is kind of what I just described. And then there's the -4-2, which is about the technical security requirements for the actual components. So here are the chapters of the -4-1. I'm not going to dive very deep here. Jussi has some more points about these, but you can see that there's the requirements, design, implementation, verification, testing, and so on and so on. But one thing I would like to point out is that this kind of makes sense. So there's no massive overhead, and you don't need to jump through hoops just because the standard says so. So this is more like a combination of known good practices in the security field. And if we look at these, you can also see that only the requirements and the secure by design parts are product specific. So each product needs to have its own requirements. But thinking about this software development process, optimally, you could have the same process for security testing and vulnerability management and update management. So you don't have to reinvent the wheel for each product. Yeah, I guess the topic of the talk was next steps for a practical approach to applying this standard. So the first step, yeah, you have to accept that you need to consider security throughout the whole life cycle. And a good way to start is just start assessing your current maturity according to this -4-1. And you might actually find out that you already have a lot of these processes in place. Moving on, now this is a pretty horrific slide, but it's just here to illustrate the scale of the standard. So on the first level, we have just the fourth part of the standard. It's divided in two. On the next level, we have 5 different sections. Then we have 15 different topics, and all in all, about 200 requirements. And it's good to keep in mind that these standards don't actually tell you how to do things in practice. So you still have to figure that one out yourself. So let's say it might just say that you have to take care of the authenticity of the boot process. And if you are using, let's say, ST microcontrollers chips, then you will probably want to use the STM32 secure boot, secure firmware update libraries for that. But in the end, some poor developer will need to go and download these libraries and read the documentation and actually write this code and implement it in practice. So it's a good idea to start implementing and getting to use this standard with just one device and chipset at the beginning. But also, because there is so much to do and it's such a large area, you will need to build a team for this. So really, people need to work together. So you will have embedded software developers, hardware developers, working with the security people who know how to secure the platform, know about application security, and of course also people who have an idea about the whole security process. And it's really important for the security people that they shouldn't be gatekeeping, they shouldn't be putting obstacles in the way of the developers, but instead all these people should be working and they should be helping these developers building these secure systems, and really cooperation is the key here. So moving on about these security levels. one big question is how much security is enough, because you can put as much money in security as you ever have. So the standard has 5 security levels, with level 0 being no security. On level 1, we're just preventing the unauthorized disclosure of information just basically by accident. So we want to prevent that someone accidentally bumps into something they shouldn't know or accidentally breaks something. And from the level 2 forward, we have an active attacker who is trying to break into the systems. On level 2, they have just low resources and generic skills, and this could well be an automated attack. On the level 3, they now have they know about these industrial automation systems. And on level 4, they have extended resources and knowledge and motivation. So if you're not sure about which level to aim for, go for the level 2. It's a great foundation, and it's the one that we are also bumping into the most. So if you need to go higher from there, it's possible. And if you're just aiming for the level 1 and then want to upgrade, it will be a lot more difficult. So yeah, like I said, my focus is on trustworthy embedded platforms. So here are the requirements that directly relate to that. And you can see that the key issues are secure boot, secure firmware update, and secure debugging, also known as security lifecycle. So here are some other standards and frameworks: the ARM's platform security architecture and their 10 goals, and ST microcontrollers STM32 Trust. And you can see that they have the similar goals here, similar requirements. So other standards have similar goals, but they have a bit different focus. So for example, the Edge consumer IoT has requirements for usability and protecting private information. But if we think about these industrial automation systems, they don't have that much private information, and they have much machine-to-machine communication, so usability isn't such a problem. This also means that once you have one standard implemented, it's easier to implement others as well, as you already have the groundwork done. And that's it for me. Now I give the stage to Jussi Valkiainen.
Thank you. So let me share my screen. Okay. Now it should be visible. So I will talk to you about the how KONE handles cybersecurity in the development phase, and I will use the KONE DX Class as an example here. So KONE DX Class elevators, they are by default connected to the cloud, so obviously ensuring cybersecurity is critical. And first, I will tell you a couple of words about KONE as a company, and then I will tell how we get the cybersecurity requirements in the elevator and escalator industry. So this is a kind of an industry-specific view into what Antti was presenting earlier. I will mention with a couple of words what the KONE DX Class elevator is capable of, and then finally present how we secure KONE DX Class by using actually the IEC 62443 standard as the guideline. And I will give examples of both process and technical requirements that we consider important to ensure security. So I will build on what Jarmo was speaking previously. So a couple of words about KONE. So KONE may be a familiar company to many of you, but still to remind you, so this is the big picture of what KONE looks like today. So we have over 1.3 million elevators and escalators in service. The technicians do over 70,000 maintenance visits daily, And maybe the most staggering number, so we actually move over 1 billion people every day. So not many companies can make that claim. And in a couple of years, all of this will actually be connected. So that is why we take cybersecurity very seriously, and we develop our solutions with cybersecurity in mind from the beginning. One requirement of secure development is that we are prepared to respond to incidents, and we are prepared to keep the software of the connected solutions up to date. And this is also reflected in the IEC 62443 requirements, as you will see. Okay, obviously we have cybersecurity requirements because there are bad actors, there are cybersecurity threats. And it's sometimes comforting to note that there are many parties actually that have identified that threats are out there, and they are defining countermeasures to the threats. This is now an industry-specific view into what Antti was showing earlier in the presentation. So lawmakers, they are not usually the first to identify a threat. But when they do, and when a law is passed, it is mandatory for all operating in the jurisdiction to follow. And some of the relevant regulations for the elevator and escalator industry are, for example, the EU Machinery Directive that is now pending update, and also the GDPR is important when we consider that we also provide some applications to the end users. So even though you might think that privacy is not that important when it comes to elevators, but when you actually have a mobile application that you can interact with the elevator, then it requires that there is some user data also stored, and then we must comply with the GDPR. Other regions have laws as well. So China has a national law for internet security that mandates that some of the data must be processed in China. And when KONE operates in China, obviously we will comply with that law. Okay, the other side is the elevator and escalator industry specific standardization. And China has been the forerunner here. This standard in 2017, it's not a cybersecurity standard as such, but it specifies already how the elevator and escalator related IoT system should work. The cybersecurity standardization began in 2018 under the National Elevator Industry Inc., which is the North American Association for elevator manufacturers. And the first cybersecurity guideline actually specific to the industry was published in early 2019. And that work now continues in an international standardization organization, so ISO working group for elevator cybersecurity. And we are expecting that the official elevator cybersecurity standard will be published in 2022. Then we might have customer or industry-specific requirements. For example, public transportation, such as airports and rail operators, will have their specific requirements that will also then apply to elevator and escalator systems that are deployed to these sites. IEC 62443. So originally developed for the process industry, but we could say that it's currently the most comprehensive standard for securing any network connected control system. And we have chosen also, the elevator industry has also chosen IEC 62443 as the reference point. As Jarmo mentioned, the standard is quite wide, 14 parts in total. Sorry, 13 parts in total. Others under development, so there may be 14 parts in about 1 year. And it is divided in parts according to the traditional process industry operating model, and we don't have obviously the same operating model in the elevator and escalator industry. So we have picked a couple of the parts of the standard that are most applicable and most relevant for us. However, even though the IEC 62443 standard is good, it's not perfect. And the challenge is that it doesn't cover cloud or the end user applications, at least not in the current versions. And for connected elevator systems, the cloud is an important component. So there are other standards that we will consider or we have to consider as well. So when it comes to functional safety, actually then when we start talking about cloud, ISO 27000 series is relevant. And as an overall framework, NIST cybersecurity framework is useful. It is not certifiable, so that is one point, that the IEC standards and the ISO 27000 series can be certified against, but against NIST you cannot certify against. Also, some other standards we investigated, but concluded that some of them can complement, but some of them are not applicable, like the common criteria, not really applicable for control systems, more for solutions that are specifically intended for security purposes. But as a result, okay, so the elevator cybersecurity standard, it will refer to IEC 62443. But then if the cloud and the application development has to be certified, it needs to be certified against some other standard, such as a standard from the ISO 27000 series. Coming to KONE DX Class elevators. So launched earlier this year, so DX basically means digital experience. And the KONE DX Class elevators, the special thing is that they are connected by default. And through the connectivity, we can offer a large amount of services to our customers and to the passengers of the elevators. You might think that, okay, yeah, elevator music, that's nice. You can see that also there on the right, but it's by no means not the only service. So very important for us and for our customers is the KONE 24/7 connected services. So it's a predictive maintenance service for elevators and escalators, and it enables us to detect already before the equipment breaks if there is some kind of malfunction going to happen, and we can send a technician on site to fix it before it even becomes an issue for the customer. So collecting the data from the elevators to the cloud, and based on then machine learning rules, they're making decisions on the maintenance. So really important service now gaining also widespread acceptance and interest from the customers. Then there is, through connectivity, there is possibility of various other third-party services also, such as, for example, delivery robots, which can use then the elevators autonomously. So the robot will call the elevator and take the delivery to the person's home. So very nice service. Also other services possible. But to make this securely, so we handle the cybersecurity now here in multiple layers, and now with the DX Class elevators we can separate 3 layers here. So the equipment itself on the left, KONE digital platform there in the middle, and then the connected digital solutions there on the right. And when it comes to standards now, then we can give this kind of view. So the NIST cybersecurity framework is the framework that provides the overall framework for cybersecurity governance at KONE. And in addition to product cybersecurity, it applies to industrial cybersecurity and also enterprise cybersecurity. But then we have the ISO 27001 standard for the digital services delivery and IEC 62443 standard for the equipment. And when now the elevator cybersecurity standard is coming, as mentioned, it will refer to IEC 62443. Okay, let's take a look now at a couple of requirements from the IEC standard and specifically now parts -4, -1 and -4, -2. So there is clearly not enough time to go through the whole standard. I will just give you some examples. As Jarmo mentioned, there are like maybe 200 requirements in total. So the timeline here that you see below, it's not it represents a generic product life cycle, and it is not a one-to-one mapping to these IEC practices, as you will see. So the part -4-1 it has 8 practices that cover the secure product life cycle, and they start with the security management, which is basically covering the whole life cycle. And I'm actually now adding privacy here because of the end user applications that need to be considered. It is obviously not part of the IEC standard itself. But the very first requirement, SM1, tells you that you must have a secure development process in place, and then the further requirements then clarify what it means to have a secure development process. Just one example, SM9, a requirement about the third-party component security. So obviously the use of open source software is very widespread these days. So that you take care and keep track on the open source components, that is a very important requirement, because to be able to keep your own software up to date, you need to keep also the open source components up to date that you are using. Practices 2 through 4 cover the security requirements, design, and implementation. And here I would like to raise the threat modeling as an important practice. So threat modeling should be started already in the design phase, and then when the threat model has been established, it can be later updated when new vulnerabilities are discovered. And it should be updated. Then come the secure design principles, such as defense in depth. So, and finally, part of the secure implementation, following secure coding standards. These can be from general purpose standards like the OWASP requirements or CWE, to the language specific standards like CERT-C or MISRA-C. And this requirement now in the secure implementation requirement in the IEC standard also includes that you should use for example static code analysis during the implementation. So it already tells you that you must do a certain type of testing during the development. And practice 5 then deals entirely with verification and validation, starting with the testing that the security requirements are actually fulfilled, to testing the system for vulnerabilities, for example through fuzz testing. So fuzzing is a very good method to find vulnerabilities. You feed a malformed input to the system and try to cause to crash or reveal information. So as you may remember, one of the worst impact vulnerabilities ever, so the Heartbleed in 2014 in OpenSSL library, that was found through fuzzing. And then also penetration testing, and the IEC 62443 standard tells that the penetration testing must be done by an independent party. So either a different company, or that it must be an independent part of your organization. So the same team that develops the system cannot also do the penetration testing. And so finally, in the process part, after the system has been developed and deployed, it will not stay secure for very long unless it's kept up to date. So the practices 6 and 7 deal with this. So you must have a process of actually also receiving from customers and your users if they happen to find some security vulnerabilities. And when the vulnerabilities are found, they should be estimated and a fix decided. And then let's say that if an outside party reported the vulnerability, the good practice is also to give them credit for finding it. So this very much in a nutshell. So I could speak 2 hours about this, but very much in a nutshell what the important process requirements are and how we consider them at KONE. Then we come finally to the security requirements. So 7 foundational requirements. These are detailed in the IEC 62443 parts 3-3 for the system level and 4-2 for the component level. And as Jarmo was explaining, the requirements can be realized on a certain security level. So there are different security levels, and the security levels are presented in the form of requirement enhancements in the standard. So that by complying with the requirement enhancement, you reach a higher security level. The security levels work in a way that you to reach a certain security level, you must fulfill all requirements in the, for example, under one foundational requirement. So you cannot just pick one and say that, hey, I have this particular requirement fulfills the higher security level, but the others don't. So to be compliant with the standard, you need to fulfill all requirements, all sub requirements for each of these foundational requirements. And now in the KONE DX Class elevator. So also here there is so much detail that no time to go in the deep details. But how this looks like in the KONE DX Class elevator. We have this view. So first of all, to fulfill the component requirements, it is required that the development process conforms to the IEC 62443-4-1 standard. So cybersecurity must be considered already in the design phase throughout the life cycle. So this will give you the compliance against the -4-1 part. Then we have in each KONE DX Class elevator, we have a unique strong cryptographic identity that connects it to the KONE digital platform. And this is just an example. This fulfills the CR 1.2, the device identification and authentication requirement, and some other requirements also in the foundational requirement number 1. And then the operating system of the connectivity device has been made more secure with multiple actions, such as hardening, CR 7.7, which specifies that you must have least functionality, built-in firewall, CR 5.1, network segmentation, and secure boot, which prevents other than our software from being installed. And this fulfills CR 3.4, software and information integrity, and EDR 3.14, so embedded device requirement 3.14, integrity of the boot process. So this is how it looks like in the end. But now I think we have run out of time, and it's time to conclude the presentation, and maybe then take a look at the questions. So I could give the ball back to Antti.
Okay, if there are no further questions, if something is coming in, we'll still answer. But I would so far like to thank everybody that has participated in this webinar, and especially big thanks to Jussi as our guest speaker. It was very exciting to hear how KONE is approaching this. And thank you, Jarmo, so much for a presentation how to implement this into practical development. And it was so interesting to see that everything starts with pretty much the hardware selection that the prerequisite is secure hardware. Very good. Thank you, everybody, and I wish everybody a good time and a good waiting time for the Christmas.